And again, don't let this sort of confuse you, because all of the, all of the information you're going to need to know is going to be given to you. You're not going to have to go find these numbers. But as I mentioned, sometimes companies might call True North and Grid North and Magnetic North are always going to be stated that way. Sometimes what you're trying to get at is the total correction. It can be stated in a number of different ways. So it's very important to know which azimuth correction your company is applying to the survey. You will need to know the total correction in order to program the MWD tool. This information can be found in the well plan, as I mentioned. So a long time ago when I first started, there was a lot of confusion with this. And they would actually made us not program the tool. So in other words, you're going to come up with this total. These numbers are going to give you a total correction for your location specific at that latitude, longitude, where you're at on the Earth. A long time ago, they made you actually add that or subtract that to your survey by hand. Well, you can imagine what kind of confusion that caused, right? So today, now, whatever total correction is going to be applied to the survey is going to be inputted into the software. So when the data, when the data is pulsed up, when the survey is pulsed up, then that correction is already going to be applied to the data, so there's no confusion, okay? But your job as a field engineer is to find out if this total correction is accurate or not. And what you're going to find is, like, if you're in South Texas or you're in Louisiana, you're looking at maybe like a 4-degree correction that's going to be, a positive. That'll be applied to the magnetic survey that's being sent up to the, from the tool. Okay? If you're east of the Mississippi River, it's going to be a negative number. So in the end, if you always work around the same area, this number's going to pretty much sort of float around the same thing, 3.8, 4.2, if you're in South Texas, But if you go to Venezuela or if you go out to West Texas, it's a positive 9 in some cases, okay? So you can see if this number is wrong and you're trying to go at, let's just say you're going, this is 0, and let's say you're supposed to be going at 10 degrees northeast, and you've got almost a 9-degree correction that needs to be applied to the survey, and you don't apply that, well, you're going to end up, you're going to, in the end, what's the word? It's the era of uncertainty. If this number's not applied to the survey, you're going to be way away from where, at the end of the well, from where you're supposed to be at. So this is extremely important, and you wouldn't believe how many mistakes are still made with this total correction right here. Eric had a friend that did one the other day, earlier this year. He didn't apply a correction, and nobody ever caught it until they finished the well. So now he's probably hundreds of feet away. This well's hundreds of feet away, possibly crossed another lease line. There's just no telling, So the exercise that we're going to talk about is just, like I said, all these numbers are going to be given to you, but total correction is extremely important because, as we said, the era of uncertainty is, if you have to apply 9 degrees as opposed to maybe, you might make a mistake. You only needed to apply a 1-degree correction. Well, it's probably not going to be too bad. It's still going to be wrong. But you can see that the further west you go, this number, the higher this number goes. And then again, conversely, on the other side of the Mississippi River, the number is going to be actually subtracted from what the magnetic survey is. But all of this is going to be found on the wall plot or on the well plan.
The total correction on the plot, it's a computed value. It's a software computing the value and put it there. A lot of well planners, they just start putting highlight on that number because it's been represented in a different way. Before, on the old softwares, we've seen it total correction. Now, they call it, I don't know, north something.
Total Baghdadi correction, it can be
So-
called a lot of different things.
As a field engineer, I mean, I've seen many guys that don't know. They just take that number, throw it there. They're not sure what it is. They seen it, they took it and put it there. Sometimes it's not the right number. So it's better to know what it is. It's not hard.
Some people call it declination also, which is not
Well,
necessarily
that's the
correct.
big, I think, as I've said before, that's the biggest part that's wrong with all of this, because it's all the same, but people tend to call it, I use the word nomenclature, but, you know, and so it causes confusion.
Yeah.
So that's what, and I know that's what Topek is saying, is that, you know, depending on the well, I'm telling you what it depends on. It depends on the software that's used to do the well planning.
Correct.
Is how they're calling it, what it is, you know? And we all worked for the same company for, I don't know, 6 or 7 years, and then we all went to work for another company. And they called it something totally fucking different.
Something different.
Yeah.
And I called the...
And you have to call, we're like, you know, we're not sure, you know?
called the coordinator and say, where's the grid conversion, total correction? And he said, hold on. It looks like he talked to the weld now, called me back. And he said, oh, he comes up with something. And I said, man, it can't be. And then I figured out it's when you make your calculation, it's what's your reference. Like now, I think Stevie was explaining your references true north or geographic north. Then you have to see the difference between that, and then the grid conversion. Because you have grid north, magnetic north, and true conversion. So you need to take the total. Sometimes the magnetic north is left of the true north, the other one is this side. So when it's left, it's negative. When it's right, it's positive. So you have to. But from where you're calculating? As
So
your
say-
reference
so say
true
one-
north.
One's negative and one's positive, you just subtract them and kind of like meet in the middle then, or what would you do?
Well, I'll draw it to make
Yeah,
more sense.
and I have some that we have, you know, they'll kind of give you a little bit better example, okay, with real numbers in them, you know?
Okay.
But
They draw it
again,
on a lot of well plans too, don't they? They kind of draw it.
well,
sometimes.
they should always, and that's one thing that I think I've got to deal with that too. It should always be on there. Grid north should always be in the very middle, pointing straight up, and then where your magnetic north is in reference to your true north. But they don't always show the calculation. They'll state the numbers sometimes, you know what I mean? But they, you know, so it's just, the bottom line is, Mario, is that, okay, I'm gonna be taking these surveys, and my job is to make sure these surveys are accurate. And so the total correction is gonna be inputted, as I just mentioned, into the software to correct the surveys that comes up. The directional hand is the guy you're gonna give the surveys to, but he's also gonna be putting these surveys in a spreadsheet, okay? So you have to agree on whatever that correction is, okay? And most directional hands are somewhat savvy. They know how to figure out, or they know what that total correction is supposed to be. But if you don't know, I mean, if it's not like, as Topek was saying, if there's a question, you know, then you have to do some investigating, maybe call the well planner or whatever, you know.
Whenever he finishes, I'll let Steve get. You remember that well plan you did the first page?
Mhm.
It was from the first day. That one explained it really well. But what I'm saying here is, you need to understand those numbers and how they came up.
You're talking about right here?
Because the web plan software, no, the other one, the other page, not the plot. Yes.
Oh, yeah, this
Yeah.
one.
Let's see here.
There's the field string dip angle. See how this is saying declination right here?
Okay.
This could possibly be the total correction. It's just the way they stated it right
Yeah,
here.
the declination is the difference between your magnetic north and your true north. This is a magnetic declination. When you get the total correction as this declination minus the grid conversion. What's the grid conversion in the top? It says 0.9 or something?
0.06.
It's 0.6.
0.06.
See right here?
Yeah, that's what I'm talking about, that's what I'm.
Okay.
Yes, you see
All right.
now, you
There's
say,
the point of
you see the magnetic north, that's what the coordinator said. I said, what's the total correction? He said, magnetic north is the total correction.
Okay.
I say, how comes? So what they did here, they just corrected, did you see
They corrected
what's in the
the-
top? It says azimuth to grid north is true north. So they corrected the true north actually, not to the magnetic north. That doesn't make any sense?
Yeah.
You know, later when you draw it, Steve, and explain it, you can understand it, but
So what did they use? See, they used 426.
Yeah,
Yeah.
if their mind's good, say something, I don't know.
they added both of them.
Mm-hmm. We're gonna look at some diagrams to show this a little bit better. You see how
They added both of them.
grid north is always in the middle?
Right, that's because your true is on the left. No, that was on the right. Then
Yeah,
you
they,
subtracted one, then it would
because
have
your
been 4.14.
Your declination was 426, and your grid conversion is 0.06, so if you subtract, you're gonna come with 4.20, that's your total correction. I believe that's how it was.